You are welcome to the Scholar Online class.
The Scholar School will establish our footprints on the sand of time. You can't afford to miss any bits of this class. Experience the difference.
Welcome to the online scholar class. My name is Mr. Abdulwasi Abdulrahim, and today I'll be your physics tutor. And today we'll be looking at one of the aspects in physics practical. Despite for our GC class, despite that this is not a practical class, but you can have an idea on what you should be expecting in the forthcoming exam. So this is alternative to physics practical, and today we're looking at experiment on light or optics. Now you are provided with this question. You can see the diagram. On this diagram, to the left-hand side, you have the object. To the right-hand side, you have the screen. And in between them, you have what we call the lens. So here we are making use of what? Converging lens. So the distance between the object and the lens is called what? Object distance, which is your U. While the distance between the lens and the screen is called your image distance, which is our V. So the image is always expected to be formed on the screen, as we have it here. So now let's look at the question. An illuminated object placed on the axis of a thin converging lens and its image produced on a screen as shown in diagram above. The procedure is repeated by adjusting the object position to obtain corresponding image positions. Then figure 2, these are figure 2 here below, shows the object's positions O1, O2, O3, O4, and O5 respectively. And our image, corresponding image distance, I5, I4, I3, I2, and I1 respectively. So, what are we expected to do here? The first question is that we have to measure and record the object distance U and the image distance V. Secondly, we have to evaluate U plus V and UV for each case. Thirdly, we have to tabulate our readings. Fourthly, we have to plot the graph of U plus V against UV. Then fifth, we have to determine the slope of the graph. Then next, we have to evaluate I over S, where our S is the slope and I is what? The image. Then state 2 precautions you will take if you are to perform this experiment. Now let's look how it goes. Then the second part of the question is this. They said an object 2.0 centimeter high is placed 10 centimeter from what? A converging mirror. Of focal length 5 centimeter. Then what is the height of the image formed? Now let's look at how we analyze this question. So based on this diagram 2 now, the O here stands for the object, while the I stand for the image. Now, how do you carry this? You use your ruler, your normal ruler, to measure the length, provided they said that 1 centimeter here is equivalent to 5 centimeter. It means that anything you measure with your ruler here, you multiply it by 5 to get the real distance that you have measured. So, how will our table look like? Our table will take this format. So you have your table of reading for U plus V against UV. This will be the title of your table. Then from the question, we are asked to evaluate some parameters. The first thing we are going to look at is our U. The second is to look at our V. The third thing we are evaluating is what? Our U plus V. And the fourth thing is what? Our UV. Now, all these are measured in centimeters. So you must put the unit, after you put the quantities, then you must put the unit by the side. So we are expected to use a slash. U in centimeter, V in centimeter, U plus V in centimeter, and UV in centimeter. Now, if you like, you can put your serial number here to show the number of what parameters you have to carry out. So you are carrying out 5 parameters. 1, 2, 3, 4, and 5. So now, starting with the first one, U That means I'm starting with O1. Now, one thing about experiment on this is that when the object is placed at a distance here, then the ray of light will travel. Let's just look at that quickly before I go to measuring that. Let's say you have this, and this is the plane. Then on this plane, I have my image object here, OB, then my image on the other side here. Now, when a ray of light travels, when it hits this platform, let's say this is our F, and my C somewhere around here. This is my F, and my C somewhere around here. Now, when the ray of light travels, this is our normal here. When it gets here, it enters through this platform. The another ray will come and follow. So when it gets to this, it will enter, bend inward, and pass through the focal points. Then another ray of light will come from this end, passing through this origin, this way, and go this way. So the way where the two of them meet is where we have our image, which is down. That is why you see that all these are what? Are under and not at the top. So the image is always what? Inverted. And that is what we are having here now. So it means that the closer to the lens here, just like what you have here, when this enter, it will go this way. Then another ray will come, pass through F. This is passing through the focal point. The another one is coming and passing towards the center of curvature here, or the center here. So to form what? To form the required image, just like what you have on this diagram. So my image here will be what? This point here, corresponding to what? To the object. So if you have to measure, we start with 5 will correspond to what? 5. 4 correspond with 4. 3 correspond with 3. 2 correspond with 2. And 1 correspond with what? 1. So starting with the first one, if I'm starting with 1, then you place your ruler from what? From the 0 centimeter point. You place it this way. That is what? Now, the first thing I'm measuring is what? I'm measuring the what? The image distance from the lens. Let's say this is the center. Please take note of this. So what about measuring? I'm measuring it. Is that I measure it from here to where it would get to the lens. So my measurement here is what? At 3 centimeters. 1, 2, 3. That means my O0. O1 is what? 3 centimeters. Let me finish measuring the O first. Then O2, I'll do the same thing. That is what? My O2 is 8 centimeters. O2 is 8 centimeters. Then you do the same thing for O3. My O3 is 14 centimeters. This is where I'm measuring it here. This is the scale, the point here. So you stop at this point here. My O3 is 14 centimeters. Then my O4, that is the object, at that point is what? 20 centimeters. My O4 is 20 centimeters. And lastly, my O5, starting from 1 as well, that is 20, starting from 1, that is 27 centimeters. So my O5 is 27 centimeters. So I'm through with measuring what? Measuring the objects. Then I'll do the same thing to measure the image now. Now remember that I'm starting from here. So I'm not going to start it from here because it's a continuous plane. So what you do is what? You still place it at what? At 0 from here, then you measure the length of the image. Now if you look at this here, from what we have here, the distance from here to here is the image distance. Distance from here to is the object distance. So if I follow the same trend, okay, we can also start the measurement from here, starting from origin as well. Let's do it this way so that it will follow suit. Now starting from the 0 mark, I'm starting with I1. As you can see, my I1 from what? From the lens here, if I'm using the lens here, is 32 centimeter. I1 is equal to 32 centimeter. Then my I2 is a 24, 25, 26 centimeter. 26 centimeter. My I3, from here again, from the origin, taking it this way, is 19 centimeter. 19 centimeter. My I4, from the origin as well, this is 10, 11 centimeter. And lastly, my I5 is going to be what? 6 centimeter. I5 is equal to 6 centimeter. So we are through with what? The carrying out the experiment. So what are you now going to do next? For each of the values that we have here, you multiply by 5. So this is times 5, times 5, times 5. Based on what? Based on the scale given to us, that 1 centimeter is equivalent to 5 centimeter. Times 5, the same thing with this. Times 5, times 5, times 5, times 5. So let's now record our value on the table. Now it depends on how this thing is placed. Assuming this is I1, you are still going to follow it from the trend here, from this point to this point, to measure your I1. But based on what you are given, this is what you are given here. So 3 times 5 will give us 15. So this is 15.0 centimeter. 8 times 5, 40.0 centimeter. 14 times 5, 4 times 5. This is 20. Then 5 times 1, 5. That is 70.0 centimeter. Then this will give us 100.0 centimeter. And 7 times 5, 35. 35. Carry 3. Then 3 times 5, 2 times 5, 10. That's 135. So that is for our U in centimeter. Then for our V, you do the same thing. 6 times 5, that's 30.0 centimeter. 11 times 5, that's 55.0 centimeter. 19 times 5, that's 0.45. Then 95.0 centimeter. 6 times 5, 30. Then 2 times 5, 10. Plus 3, that's 30. And lastly, 32 times 5. We have 0, 3 times 5, 15, 16. So that is all, that will be, this is how our table will look like. Now, our U plus V, meaning whatever you have here and whatever you have on the second column, you are adding it together. So 15.0 plus 160.0. Now look at it here. You see that I placed all of them to be one decimal place. In experiment or this, you don't use round off value. So you must always put what? The level of decimal place should be at least 1 centimeter for length, if you are measuring length. So that's why everything is what? 0.0. So we are adding our 15 plus 160. 160, 15 will give us 175.0. The same thing, 140 plus 30, 40 plus 130. 130, 40, that's 170.0. The next one, 95 plus 70, that's 16, 165.0. The next 100 plus 55, 155.0. And lastly, 135 plus 30, that's 165. 160. 165.0. 5, 135, 45, 7 times 5, 35, then 2 times 5, 10, 35, 35, 2 times 5, 10, 135. Okay, that's correct. So this plus this gives us 165. Now, if you look at this, the trend of the table, you have 175, 170, 165, 155. So this one deviates. Ideally, the value should correspond with what? What you have here. So this one deviates. So you check through your experiment, and if nothing is wrong, then you can leave this. It means this one does not what? Follow the other trend. So let's leave that. Then for the UV, we are multiplying this and this. So that will be the first one, 160 times 15. 15, 16. 30. 6 times 5, 30. 6 times 1, 6. That's 9. 5. 1. 0, 4. 240. 0. The second one, 130 times 40. 3 times 4, 12. 4 times 1, 4. Plus 1, 5. How many zeros? 2 zeros. Okay, 130 times 40. So that gives us 5, 2, 0, 520. Then the next one, 165. 165 times 7. 7 times 5, 35. 7 times 6, 42. 45. Then 7 times 1, 7 plus 4. That would be 11. That's 1155.0. The next one, 100 times 55. That will be 5500.00. And the last one, 135 times 165. 135 times 30. 135 times 3. This is 15, 0, 3 plus 1, that's 4. So I have 405, 4050.0. So we are through with what? Turning out what? The analysis. So the next thing is now to go to the other part of the questions. So this is our table here. We have the first one, 240, 2400, 5200, then 115.0, then 550, then 4050. So let's now look at where to plot the graph. Now, if you look at this graph, because it's not because it's a what's it called now? Because it has to do with what? Mirror or lens. You see that the values are juggling in between 240 to 52, 52. Then the value what falls down again, then it rises again and it falls. So let's say what's now the question? Evaluate U plus V, which we have done here, and UV, which we have done here. Then tabulate your reading. That's what we have done here. So mere doing all this, the table alone, each of the column has its own mark with what the corresponding values that you have put on the table. And also don't forget your units by the side. All these are what you look out for when marking your exam. Now you have to tabulate or then plot the graph of U plus V against UV. That means on the vertical axis we are going to have this, and on the horizontal axis we are going to have UV. So how do you pick your scale? Based on what you have here. So in picking scale, we are to plot U plus V against UV. You go to the column for U plus V. The highest there is what? 175. And the lowest is 155. Then when you go to the column of UV, the highest here is 5500. And the lowest is what? 1155. So to make the work very easy for you, you can decide, if you are not the type that like big figures, you can divide all of them by 100. So if you divide by 100, all this one will reduce to what? 1.75, 1.70, 1.65, 1.55, and 1.65. If you do the same thing here, this one we have 24, 52.0. This one will be what? 11.55, 55.00, and 40.50. At least this one will be what? Within what you can what? Reckon with. So from what I have, you see that everything is what? Less than 2. Why this one 24, 52, 11? So everything here is what? Just 60, within the range of 60. So if I want to pick my scale on the vertical axis here, so graph, title of your graph of what? U plus V in centimeter against UV / centimeter. This will be the title of your graph. That's the first thing you write on your graph page. The second thing is what? You write your scale on your graph page. And how do you write your scale? This is not mathematics graph. So it's not Y and X you are plotting physics graph. So on the vertical, as you say what? 2 centimeter represents, let's say 1 unit on U plus V axis. That's an assumption. Then for the other one, you can say 10 centimeter or 2 centimeter to represent 10 units on what? UV axis. This is how you write your scale for physics. Now, let's now look at the scale. I said the highest here is 1.75, which means the value is not up to 2. So we can use a scale of 0.5, 1.0, 1.5, and 2.0. This only accommodates 4 points, 1, 2, 3, 4. And on your graph page, you have up to at least 8 boxes or 10 boxes. So you can either go with this or you go with 0.2, 0.4, 0.6, 0.8, 0. But if you use this one here, it will not be able to accommodate it. So the best thing is what? To stick with what? 0.5. So it means that 2 centimeter represents what? 0.5 units on the vertical axis. I hope you are with me. Then on the horizontal axis, the maximum here is what? 55, which is approximately 60. And the lowest is 11. So you can still use the scale of what? 10, 10 here. So you can say what? 2 centimeters represent what? 10 units. It means that each box that you have on your graph, let's say this is what you have here. This is our box here. If you are starting from the origin, this is 0. The next point will be what? 10. The next one will be what? 20. The next one will be what? 30. That's the meaning of what? 10 centimeters, because the box here is 2 centimeters. One of the box is 2 centimeters. So 10, 20, 30, and that's why you continue up to what? The level you have. But remember that your values here are what? 2,400, 5,200. So that's exactly what you are going to use. But this one is just to give you an idea of what? Picking the scale. Now let's plot the graph now. This is my vertical axis. This is y-axis. This is my x-axis. So on this vertical axis, you write what? U plus V in centimeter. While here you have what? UV in centimeter. This is how you title your graph. And don't forget your origin. So one thing that must be on your graph page, first thing, the title of the graph. Secondly, your scale. Then the next thing is what? When you draw your axis. On the vertical axis, you have U plus V. That will be the normal title. On the horizontal, you have what? UV in centimeter. Then your origin. Now, based on the scale that I said, say 2 centimeters represents what? 0.5 units on the vertical axis. And that's what you have is just what? It means these are 3 digits. So if you multiply this by 100, that will be what? Multiply by 100, that will be what? 50. So it means that this is going to be what? 1, let's say these are my scales here. 1, 2, 3, 4, 5. So this will be 50.0, 100.0, 150.0, 200.0, 250.0, which would accommodate what I have here. Then going back to the horizontal axis, we said what 10 units to 2 centimeter. So here just multiply by 100 back again to give us our normal units. So it means that this is going to be what 1, 2, 3, 4, 5. So this will be 1,000, 2,000, 3,000.0, 4,000.0, 5,000.0, and 6,000.0, which accommodates because the highest is 5,500. So you have everything intact. Now let's plot the graph now. So plotting the graph here now. Plotting the graph, we are starting with the first one. When U plus V is 175. 175. Remember that the box here. Sorry, we're not using the normal graph. The box here remember that for the box here we have what 10 spaces. So that's what we have here. So using this as a case study, it means that each of the line here, you look at the margin between the space between this and this what? The interval between this what? 50. Are you with me? So to now get each of the lines, it's going to be what? 50 divided by the number of holes. How many holes do you have here? 10. 50 divided by 10. It means that each of the line is what? 5 units. So this is 5, this is 10, 15, 20, and that's how you read it. Each of the line. The same thing for this one. For the horizontal axis also, this is 1,000 divided by what? 10 spaces. And that will give us what? 100. It means that each of the line for the horizontal is what? 100. So if I want to read 175 for the vertical axis now, this is 150. This is 150 and 200. So the middle of 150 and 200 is going to be what? 150, 0, 5, 3. Divided by 2. 2 in 3, 1. 2 in 15, 7. That's 175 exactly. Wow. So this is the middle of what? This and this is 175. So when this is 175, on the other is what? 2,400. This is my 2,000, this is 3,000. Add it together. 20 plus 30, that's what? 50. Divided by 2, that's 2,500. And I need 2,400. So 2,500 is the middle. So 2,400 what? Closer to that point. So you trace the point together. 175. Then you what? Is either use asterisk or use what? Circle and a dot. Then the second one, when our U plus C is 170. 170 will be closer to 175. Let's say this is it here. Then our value is what? 5,200. This is 5,000, this is 6,000. Middle is going to be what? 5,500. And I have 5,200. So let's assume it's here. You take it up to what? 75. Then you join the point together. The next one, 165. When U plus is 165, 165 will be in between 175 and 150. Let's assume it's here. Then our value is what? 1155. 1155, that's between 1,000 and 2,000. So by assumption, 1,000 and 2,000, that was 3,000 divided by that's 1,500, and we need 1155, so it will be before the middle line. Let's assume it's here. Join it together. Then the next one, 155. 155 closer to this. So you can see that the graph is very skewed to a particular point. Then what do we have here? 5,500. 5,500 will be around here, closer to 6,000. So we have this here. Bring the points together. And lastly, 165. 165. 150, 165. I think we've taken that as the middle of these two again. 165, then you have what? 4,050. 4,050 closer to this point. 155. So this is what you have here. So we have plotted the 5 points. So you now look at what? Out of the 5 points, the 3 best line of fits. So just like what you have here now. If you look at, according to our law of mirror, how do you know the pattern in which your graph is going to take? If you look at the mirror image, the mirror formula, 1 over u plus 1 over v is equals to 1 over f, right? Then when we multiply all through by, or find the LCM of this is what? uv. So u cancel, we have v plus u is equals to 1 over f. Which means that what we are asked to plot is what? The inverse of the focal length. U plus v on the vertical, uv on the horizontal. So since it's inverse of the focal length, then you are supposed to have a straight line graph following the what? The other direction. Which means your graph should go this way and not this way, based on the formula that we have there. So if you invert it, you can also have what? uv over v plus u is equals to what? F. So if you have this, then it means you are going to have the line going this way. But if you have this one now, you are going to have it going this way. So our graph should go this way, passing through the origin. So we have just 2 points here. That's the only 2 points that can what? Match. So this is not a best fit. So you join your points together with what? A ruler or a straight ruler. So this is what is going to be our graph passing through these points. So in order to take the slope, mind you, these 3 points are supposed to fall in the line, but provided you have 3 points, it is still satisfactory. But what you have here, because of these 3 points here, it can be what? Due to the reading from our table or from the diagram. So the error can emanate from there. So let's now look at the next part of the question. The answer we should what? Determine the slope of the graph. In taking a slope, you look at any point here, any point on the graph to take your slope. So if I'm using this point here, and I'm using this point here, then you must what? Form a triangle. So this is my slope, A, B, and C. A, B, C. Your slope must be big enough to accommodate most of the points. Otherwise, it's going to give you a wrong value when you use a smaller slope. So what is our slope here? Our slope is defined as change in what? U plus V all over change in what? UV. And when you say change, that means you are comparing 2 values. So it means for my slope here, the higher value at C minus the lower value. So you are looking at C here. Trace it to what? To the y-axis. That's the upper value. Then the lower value is the one down here. So if you trace it to the upper value, this is 200. Let's assume that this is 250. 250.0 minus the lower value here, which is what? 150.0 divided by our UV. The same thing, trace this down. That's 4,000.0 minus the lower value here, which is what? 1,000.0. So when we subtract 250 minus 150 will give us what? 100. Then 4,000 minus this will give us 3,000. 2 zeros cancel 2 zeros. So I have 1 over 30, which is as 0.0333 and so on and so forth. So since both of them are of the same unit, the slope will not have unit, but it will just be this. So our slope is 0.0333 and so on and so forth. So that is our slope, which is our S. Then the next part of the equation, we have to evaluate I over S. You have to evaluate I over S. Our I is what? The image. And our S is what? The slope. So our I here, we stand for what? The initial length of the image from the screen. And which is what? That is a last value here. The last value here, which is our I1. And our I1 is what? 160. So it means that my I over S is equals to 160 divided by the slope 0.0333. That'll give you your value as well. That'll give you your answer. Then the next thing we have to do, so use your calculator to get the final answer. You have to state 2 precautions you would take if you are to perform this experiment. Just like I stated earlier, if you are carrying out this experiment, when you say precaution means what? Those things that you have to put in place when you carry out the experiment. The first thing is that this experiment is on light or optics. So the first thing is that there must be presence of what? Availability of what? Light, ray of light, so that you can easily see the image clearly. Then the second is that what? The object must be erect and must be placed in front of the screen. So if you have to state it, you will state it as what? I will ensure that the object is erect, then also is what? Placed in front of the screen. Secondly, I will also ensure that what? There is what? A presence of what? Ray of light, so as to see the image form on the screen properly. Thirdly, I will ensure that the image form is not blurred. BLURRED. That means what? It is visible enough so for you to see. Then these are some of the precautions you have to take when carrying out this experiment in the ray form. So after you have done all this, remember that all this carries 25 marks, including the B part. So now the B part now is now to evaluate your knowledge about the lenses or image and object formed by lenses. So let's look at the B part, and that's the calculation aspect of the experiment or the alternative practical that we have explained so far. So the B part, they said an object 2.0 centimeter high. So we have object height. Object height is equal to 2.0 centimeter. In a proper aspect, we use object as our U. Then is placed 10 centimeter from what? From a converging. So that's object distance. Object distance 10 centimeter, 10.0 centimeter. So let's use the object height as H. H naught. To differentiate between the object distance, which is U. Now, is placed what? 10 centimeter in front of converging mirror. Our focal length 5 centimeter. Our focal length F is equals to 5.0 centimeter. Then what else? What is the height of the image form? So height of the image, or let's say image height. Image height, that's what? HI, unknown. So these are what are given here, the parameters that are stated here. We are given the object height, no image, we are given the object distance, and we are given the focal length. Now, the formula that connects this, we have two formulas. The first one is what we call the mirrors formula, or lens formula. So, and that is 1 over U plus 1 over V is equals to 1 over F. Since it's converging lens, everything will be positive. U stands for the image object distance, V stands for the what? The image distance, and F stands for the focal length. So since this and this is given, then we use it to get our image distance. Then after that, we can now get the image height using the other formula, which is what we call magnification. So from what I have here, I'm looking for this now. So I'll make it such that means I have 1 over V is equals to 1 over F minus 1 over U. By substitution, 1 over V is equals to 1 over, our F is what? 5. Minus 1 over, our U is what? 10. So we take the LCM of these two. The SM is 10. 5 in 10, that's 2. 2 times 1, 2 minus 10 in 10, that's 1. So I have 1 over V is equals to 1 over 10. So if you reciprocate it, we have therefore our V is equals to what? 10.0 centimeters. So this is my image distance. Remember, we have to find what? The image height. So according to magnification, we define magnification M as object height over, we define as what? Image height all over object height, or image distance. Image distance over object distance. So if I follow that trend, that means my M is equals to HI over H naught, which is also equals to what? V over U. So this is the ratio you are going to use to get the HI, which is the image height you have to find. So using that ratio, HI over my H naught is given as what? 2.0 is equals to V, which is what I got in there, 10.0 over U. What's our U? That is also 10.0. So from what you have here, HI over 2.0 is equals to 1 over 1. So cross multiply. So therefore, HI is equals to what? 2.0 centimeter. So hence, our image height is equals to 2.0 centimeter. So, thank you.